who you are and where you are two of the ways that society coheres. And this is my colleague, Bill Hillier, who very sadly passed away last week. And so I thought I'd put in a tribute to him here. But he said there are two primary social networks that hold society together. There's a spatial network of who you meet in space, who your neighbors are, who you run into in the street. And then there's a network of those things that are to do with your category, who you are. You might be a professional. I'm an architect or a university professor. I'm male. There's a whole series of aspects of me as an individual that allow me to say I'm similar to others or different to others. The second person that I wanted to mention is Emile Durkheim, the French sociologist, one of the founding fathers of sociology, who produced a pair of other things about the way that society holds together. He said there are mechanical and organic solidarities. This is very French, of course, to have to invent a jargon. But I'm putting it down in Anglo-Saxon as birds of a feather flock together, which is a mechanical solidarity. We group together according to our similarities and our shared interests. And opposites attract, which for him is the organic nature that the human body or the animal body has lungs and heart and limbs and brain. And without any one of those, it can't function. It needs all the parts to work together. And so in a social structure, it is that in an organization, you need these various different specialisms together in order to collaborate to achieve some purpose, some functional purpose. Now, the mechanical solidarity of similarity you can see every week at a football match. We all go along and we all cohere according to the side that we support. And it's very much of a sort of gut feel of being there and all sharing in a communal experience. The other aspect, the organic solidarity, we also all participate in various ways depending on what our work is and what our lives are. So an example of that would be that in work organizations, the ability to find other people useful. This is where I'm putting together space and the organic solidarity, if you like, is something that relates to how often they're seen. And the pattern of space in a building dictates how you move around, but it also dictates how you're brought into contact with others. And in doing that, it creates a virtual community, the possibility of contact. And that possibility of contact is what gives rise to networks, social networks of who knows who and who finds who useful in their work. So it's not only about who you see most frequently. There's a particular kind of structure to this scattergram which is sort of expanding as you're going up towards the top right. Frequency is going across horizontally. How many people you know is vertically. And each of those is an individual. Top left-hand, or top right-hand side, the person who's the most seen and the most useful happens to be an IT person who keeps the network going. And it's not a surprise, their job is to be useful. Yeah, that is their role in the organization. It turns out that the bottom two left ones on the left-hand side there, one is a director of the company who'd been away on a sabbatical the previous year. And that meant that he'd not been seen around much, but he was still recognized as being useful. He had the company's knowledge, he signed the expenses checks, I don't know, the various reasons why he would be useful. But that shape of scatter suggests that there's something else going on, and that something else we could unpack, I'm not going to do it here, into the different functional groups within the organization who bear different relationships to others. If you're there to be useful to everybody else, like the IT person, you end up right at the top. So similar sorts of things seem to go on in urban space. We construct cities in order to bring people together and to keep them apart. And this is a little map of 19th century East End of London, around Commercial Road, Mile End Road, actually. And the colouring up of the bottom section is Booth's map of social class in London. And you can see that what happens is that along a street, you have a similar class. So all the red middle class going along the Whitechapel Road or the Commercial Road. You turn the corner once or twice and you can be into one of those black areas of social class, which are the vicious semi-criminal classes of Booth's classification. That's the JGO, where police officers had to go in 2 at a time and so forth. That mapping between space and social class is actually a very interesting phenomenon. It's something which we see today, not so much to do with social class, but much more to do with land use. So this is the area, actually not far from here, up to Oxford Street, Regent Street. And if I put in their land uses, you can see the red in this terms are the retail, blues and yellows are different land uses, commercial and residential and so forth. And there is a relationship, a correlation between spatial structure and land use and property value that runs through the market, if you like, in property. This is something which happens without planning. It's a naturally emerged phenomenon. This is all sort of pre-1948, so it must be without planning. And there's an immense inertia in urban systems in producing this kind of patterning and structure. Now, we can take those same methods of spatial analysis and apply them at a much larger scale. So this is a map of Western Europe, space syntaxed, to give you a pattern of closeness, centrality, as the mathematicians would call it, but essentially a pattern of how accessible each piece of space in that system is to every other in that system. As you can see, the line that takes you through Eastern Europe from the lowlands right the way through Poland and off towards Russia. This is an amazingly integrated and accessible chunk of the world. And it relates to other things that we see. So my next slide shows a piece of work produced by a couple of researchers who are looking to find how accessible to a town is every piece of space on the planet. And they're interested in this because of malaria and malaria spread. And the accessibility here is in hours or days. So the dark blue color is days. Red is more than an hour and up to a day. The yellow-white colors are less than an hour. And you can see the bulk of Europe, you're less than an hour away from a town anywhere that you are, just about. There are bits of Spain which are a bit more remote than that. But apart from that, Europe, by and large, is an hour from a city or less. The west of the states, particularly the Midwest around the Great Lakes, is also very accessible to cities, but very rapidly you end up in those deserty, mountainy bits, and it's less so. And of course, you get more accessibility over on the far west coast. India, remarkably urbanized and remarkably accessible. And of course, the far east of China similarly is increasingly accessible. We can take a map of shipping. So this is the current map of shipping flows around the whole of the world. And that is particularly important, not so much for passengers anymore, but particularly important for goods and how those flow around, and very much dictated by the morphology of the oceans into those areas which are accessible and those areas that are less so. And of course, that's subject to change because with the melting of the ice cap, the Northwest Passage is opening, and that will change and shift the geography again of the whole globe. So that's going on now. This is the railway map of the whole world. And you can see there, obviously, the effect of where the British have been. We like railways. And we seem to have built them in all sorts of places, including Argentina and China. But it's a bit of a more patchy map, actually, but Europe incredibly well served, as is the western side of North America. And then, of course, with air transport, that is much more flexible. It's point-to-point, and it's much cheaper to decide on what you're going to do to reroute an aircraft to somewhere else. Of course, keeping the aircraft up there in the air takes an awful lot of carbon, and that's a problem that we're all going to have to find a way through in the near future. Now, we're in another period of rapid innovation. People are talking about sensor networks, Internet of Things, big data, robotics and autonomous systems, biometric ID, distributed ledger technology that Richard mentioned, artificial intelligence. I haven't put dates against any of those because for me, none of them are quite there yet, but they are all about there now. You know, this is all happening within a matter of years. These things will be real and will be making radical changes. So we've got a very, very rapid acceleration of what's happening. So that's the internet, and this is sort of where the main fiber runs go. You can see that it's much easier to lay them in sea than it is to lay them across land. And so the coastal bits get the fiber runs coming into them. This is very much like it was in the days of sail and steam ships. The geography takes you back to coastal regions, actually, for where the main inputs come. And then, of course, the effect of this. And there are wonderful big data that appear now. So this is a mapping of IP pings through the day. So it's animated through day and night, according to where traffic is taking place. And it's a remarkably beautiful kind of image, which I haven't quite got on top of in my head yet about exactly what it means. But there are certainly parts of the world that seem to wake up at different times, and it's not necessarily the way you would imagine. So there's probably a whole lot of people who seem to be working at night rather than in the day because of this internet. Not very good for you. Well, my line about this is that the digital is a human invention. We can't separate out the digital world from our human universe and say it's happening to us because we have made it and it is our product. If we are trying to separate it out and say it's not a part of society, we end up with a real philosophical kind of, spiral. So I'm going to give you two examples where the use of the digital, I think, can be positive. And the first one is from a few years ago. It's the use of the digital to model and simulate what you can do to this patch of space in London. This is Trafalgar Square as it was last century, when it had a big retaining wall up to the National Gallery on the north side, and flock of pigeons. Not much else, to be quite honest. They had tourists in there with the pigeons. And so the little red dots there are not pigeons, they're tourists. The blue lines are Londoners wandering around, and by and large, they don't walk across the body of the square. Now, at that time, John Prescott was in charge of the environment, and he set a competition going. And the competition was what he called World Squares for All. How can we turn Trafalgar Square and actually the one just outside here, the one in front of the House of Parliament, into something that is more sociable and more cosmopolitan? And that was the challenge. And so in that project, Bill Hillier was advising Norman Foster, who came up with a scheme. And the scheme was a very simple one. It was to replace the central section of the wall with a new staircase and to pedestrianize the northern piece of road system around the square to allow you to walk across and through. And this is very difficult because that wall was Grade 1 listed heritage. And you're asking us to demolish it. And so, of course, the whole thing went to an inquiry. And the work that we did here was all about giving the proof of evidence to the inquiry to allow the inspector to decide whether or not demolishing that would be justified. What he came out with at the end of that is mostly what these inspectors do is they class the evidence they get into evidence of opinion or evidence of fact. And what he laid this evidence down as evidence of fact. What we've got here is a predicted increase in pedestrian movement rates across the body of the square. Now, actually, if you've been to Trafalgar Square since that, you'll know the transformation. It is well used. It is a complete transformation in what the space feels like, but also in the patterns of the way that people move through it. And so what we've used there is the spatial analysis, the computational analysis, to help us intervene, to actually improve what we believe is improve, or at least to do what the brief asked for, which is to turn the square into a square for all, so that people moving through on their routes would be brought into contact with those who are going to the square as tourists to take a photograph on a line. And that transformation is something which I think comes about because of technology, but also because of the field of science of understanding human behavior and how it relates to spatial structure. I think that the one thing I would say about that is that that's just an example of how better forms of computation and analysis and science can help us to transform the space of real places and do placemaking. My second example is a prospective example, and it's one that comes up on the back of Grenfell, where Dame Judith Hackett, wrote her report on building a safer future. Now, she illustrates the regulatory structure of fire regulation and fire safety on the right. And this is one of those rather nice systems diagrams, which if one was doing an oil refinery, one would probably say, well, it's a relatively simple one. But as a piece of regulatory framework, this is anything from but simple. It's a complex human set of relations and really difficult. So how do you intervene in that? Well, she has a brilliant suggestion. Her brilliant suggestion is something called a golden thread. And she says, what we're going to do is we're going to create a golden thread through the information that surrounds a building. And the structure of that, let me give it very, very briefly here, just as a sketch. You have a building information model, and in the future, it's likely that most buildings of any size and complexity will have a BIM model of some description on which they're based. But imagine that every item, every piece of cladding with flammable foam in it has embedded in it a chip at manufacture that verifies that it is what it says it is on the tin. And it's not a fake cladding panel that just purports to be what it is. So something authenticatable, difficult to forge. Imagine that every time somebody touches that project, their identity can be logged. This may happen just at key target points in stage gateways, maybe through the project life. But say that when the building design gets signed off by building control as a good design, that the building control inspector or officer, biometric ID, we know it's you. You signed that off. And imagine that when the inspector on site turns up and inspects on site, maybe they're wearing one of those body cams that the police now wear, so that you can see that they've actually inspected inside the cavity and can see the cavity barriers are in place. Fascinatingly, they don't always seem to be. There seem to be a lot where they aren't. Now, how do you keep all of that? Well, that's the trick. The trick is this idea of the distributed ledger. The real trick is actually the immutable aspect of that. So cryptography lets you take a particular document and then compress it into a very, very short hash. And a hash is just maybe 32 bytes of code that just say all the information here compresses into that through a cryptographic algorithm. The beauty of this, by the way, is that if two documents are very similar to each other in their original form, the hashes are guaranteed to come out as very different to each other. If they're very different, they may end up with quite similar hashes, but then you'll have a very clear ability to distinguish. So there's a very wonderful thing about hashes and cryptography that allow that to happen. It means you don't have to keep the whole BIM in a form. You just need to say this BIM model with this form had this hash. This piece of video from my body cam had that hash, 32 bytes each, very small amounts of code to be kept. And then you have the next fire, and the inspector, the Judith Hackett or whoever wants to review the information. Well, at that point, they can say, I want to see that golden thread record. And I want to see the original data that you may have held on to as a data owner. That hasn't been given to somebody else. You have a responsibility to hold that. And at that point, you've got something which shines a light on all the individuals in the process. Now, we've heard for many years that the construction industry has a series of cultural problems. Amongst those cultural problems are really those of trust. They are, can I trust that the person who did this actually did it to specification? Is that drawing what was actually built? And that trust issue is something which, shining a light, just the ability to watch what somebody has done and to them not to be able to claim that it was somebody else that day that did the inspection because you've got their biometrics, that will transform culture, I believe.